Hello, my name is Mrs. Smithy. I teach second grade at Stockwell Elementary, and welcome back to our virtual classroom. Today is day 6 of our math lessons, and you will need the day 6 worksheet along with your pencil here in a little bit. The code word today is ice cream, so take a moment to write that down on your worksheet. And we are going to go ahead and start with a refuel. So we are going to do another yoga flow from Yogavate, and we're going to be practicing some poses today. I'm going to have you practice along with me. So you're going to need to make sure that you have a little bit of space to work with. You're going to stand up for these positions and make sure that you're not going to touch anything or knock anything off. All right, so we're going to practice some different tree poses. When you're a tree, you're going to stand nice and straight and tall. So we're going to be standing for these. And the first position, we're going to start in our ready position. So just stand with your feet together and your arms down to your side. You're going to cross one foot in front of the other. It does not matter which foot. So you're going to take one foot and you're going to cross it in front of the other. Now you'll have to practice on your balance here. It helps to focus straight ahead on something, and it kind of helps you from wobbling, okay? But it's okay if you wobble. Now, it also helps if on the foot that's on the ground, you press those toes into the ground. That'll help you with your balance also, and make sure that you're nice and sturdy. And then you're going to place your hands on your hips, okay? So we're gonna stand here and we're gonna count to 3. So it's okay if you wobble or you mess up, just go ahead and get back into the position. I'm feeling a little wobbly right now. 1, 2, 3. All right, and then you're gonna put your foot back down and go right back to our ready position. The next one we're going to try, you're going to start in that ready position again, okay? And you're going to lift one leg up with your knee facing forward. Again, it doesn't matter which knee you do. So you're going to lift your knee up. And then your arms are going to reach forward and your palms of your hands are going to face up. So just like this. We're going to hold this for 3 seconds. 1, 2, 3. Let's try it on the other side. So go ahead and put your hands down, and your other knee that you didn't do, go ahead and bring that one up. Nice and slow, get your balance, and when you have your balance, go ahead and raise your arms up. 1, 2, 3. Great job. All right, this one's a little more challenging. So you're gonna stand again in your ready position, okay? You're going to touch one foot to the inside of your opposite calf. So you're going to lift it up, and you're just going to put that leg right up there, kind of bent. When you have your balance, you're going to sweep your arms up and over your head, and your elbows are going to be kind of bent, but your palms are going to come together. And take some nice deep breaths. 1, 2, 3. All right, you want to try the other side? Go ahead and lift your leg up. When you have your balance, go ahead and move your hands up above your head. Leave them bent. Remember, you push your toes down to the ground, and that'll help you stay sturdy. 1, 2, 3. All right, we've got one more. This is a fun one. It's called the star pose, and it reminds me of a big stretch. Sometimes that feels really good. So you're going to stand with your legs spread out wider than your hips, and you're going to raise your arms 45 degrees. That is not straight out. That's kind of up like this. Take some nice deep breaths. 1, 2, 3. Bring them back down. All right. Go ahead and get ready for our lesson. Have a seat. And our target today is I can use addition and subtraction within 100 to solve real-world problems. So we've been doing addition. We're going to solve problems using addition and subtraction today. I can represent my answer using drawings and equations. We're going to work on giving evidence, writing an equation with a missing part, and then solving that problem using a strategy. So we're going to jump into our first word problem today. The second grade class voted on ice cream for a reward. There were 91 students who voted. 36 students voted for vanilla. The rest voted for chocolate. How many students voted for chocolate? The first thing we're going to find is that question that they're asking us in the problem. Do you see the question in this problem? How many students voted for the chocolate? So are we missing a part or are we missing a whole here? We know the vanilla, we're missing the chocolate, so I'm going to put an X right here. We don't know how many chocolate votes there were. So that is our missing part today. Let's go back and chunk our problem and find what information we do know. The second grade class voted on ice cream for a reward. Is that information that could help us solve the math problem? No, but it does help us make that movie in our head so that we know what we are supposed to do for the problem. There were 91 students who voted. Is that 91 students who voted for part? Or is that the 91 students who voted, is that the whole? That's the whole 91 students. That's everyone who voted. 36 students voted for vanilla, so we know that part. 36 is part of the students, they voted for vanilla. The rest voted for chocolate. Do we know what number voted? No, it just says the rest, so that's our missing part. Now, we've created equations from our part whole or our bar model before, and that's the next step we want to do, so we know if we need to add or subtract. One equation we can make from this model is we can start with the part that we know, see how many we need to add on, and get our whole. We practiced that within 20 before. So I'm going to start with my 36. I'm going to add, we don't know how many yet, and that will get us to 91. So that's one equation we could write. Another one is we can take the whole that we know, take away the part, and then that will be left, we'll be left with the other part. So we have 91 in all. If we take away the 36 students who voted for vanilla, we should be left with how many students voted for chocolate. We're going to use two strategies to solve these problems today. We're going to use our base 10 models again, and we're going to try a new strategy, a number line. So let's start with our base 10 models. Now when we are subtracting, it's very similar when we add. We still use the rods and the units, but we're taking away when we subtract. So we won't be putting both of these numbers down. We'll be taking away some numbers. So let's see what we start with. 91. That would be 10, 9 tens, 10, 20, 30, 40, 50, 60, 70, 80, 90. And 1, 1. So we're starting with 91. If we're going to take away 36, that means we need to take away 3 tens and 6 ones. Do you see 6 ones there? I only have 1 1. What can I do to get some more ones over there? Well, we put a group of 10 together to make a 10, or we put a group of 10 ones together to make a 10. Do you think it could work backwards? Could we ungroup a 10 and smash it into 10 ones? Yes, we can trade this 10 and we can make it 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have enough to take away 6. Okay, so I'm going to take away my 6 ones. 1, 2, 3, 4, 5, 6. And I like to circle how many I have left so that I can keep it organized. And then I'm going to take away my 3 tens. Now, we can't count this one. This was just a trade. So we have to take 3 actual tens away. 1, 2, 3. That leaves me with 1, 2, 3, 4, 5. 5 tens and 1, 2, 3, 4, 5 ones. I got 55 as my answer. Let's see if we can get the same answer using another strategy. Now when I use the number line, I can count backwards or forwards, but for this one, we're going to start with the part that we know, so I'm going to plot 36 on my number line. And then we're going to see how many we need to add to get to 91, and that will be how many votes were for chocolate. So the first thing I'm going to do is try to get to my friendly number. What friendly number is really close to 36? 40. How many would I need to add to 36 to get 40? 37, 38, 39, 40. I added 4, and now I have 40. Well, I know that I could count by tens all the way to 90. So if I count by tens, 50, 60, 70, 80, 90, how many is that from 40 to 90? That's a jump of 50. If you need to make small jumps of 10, you could do that. You can do a hop of 10, 10, 10, 10, 10. I just made one big jump of 50 because 10s are kind of easier for me to add. Now, we don't need to get to 90. We need to get to 91. So I need to add one more. Now, what did we have to add that got us to 91? 50 and 4 and 1. Well, I know 1 and 4 make 5, plus the 50 would be 55. Those are two strategies that you can use to solve those bigger math problems with the larger numbers. We're going to watch a Learnzillion video, and as we're watching this video today, I want you to be thinking about this question. Why is it helpful to know more than one way to solve a problem? Why do you think it would be helpful?
How do you choose a strategy for explaining addition and subtraction? In this lesson, you will learn how to explain addition or subtraction by choosing appropriate strategies. Remember that there are many reasons we explain in math. Sometimes you need to prove to other students and teachers that you are correct. Other times you are comparing your strategy with others to see how they solve the problem and maybe learn a different way to think about it. Finally, you might explain how to solve the problem to someone who doesn't understand. There are many ways to explain your solution to an addition or subtraction problem. You might use place value, breaking the numbers apart into tens and ones. You can also break the numbers apart in a different way. To subtract 32 minus 14, you can break the 14 up into 2, 10, and 2, and subtract each part. The relationship between addition and subtraction, or fact families, can also help explain your work. For example, to prove that 95 minus 61 equals 34, you can prove that 61 plus 34 equals 95. A final strategy is to use the commutative and associative properties of addition. The commutative property says that we can add numbers in any order. So we could change 30 plus 7 plus 10 plus 6 to 10 plus 30 plus 7 plus 6. The associative property says that we can group numbers when we add. So we could group the 10 plus 30 as 40, and 7 plus 6 is 13. These strategies all make it easier to explain your work. But the big question is, how do you know which strategy to choose when you're explaining? Let's think about a couple of problems to help us answer that question. The cafeteria has 48 tables. Students put flowers on 17 of the tables. How many tables still need flowers? The monkey solved this problem and his answer is 31. Now he needs to choose a strategy to explain. When you're choosing a strategy, think about the numbers in the problem. Pick an easy but clear way to explain your thinking. For this problem, the monkey was able to simply subtract ones from ones and tens from tens. So place value is an easy way for him to explain his thinking. He can use some numbers, words, and a picture. 4 tens minus 1 10 is 3 tens. There's the words and picture. 8 ones minus 7 ones is 1 ones. Some words and numbers, and a picture. All this proves that 31 tables still need flowers. Let's look at one other example. For snack time, the second graders need 39 popcorn boxes. The first graders need 43 popcorn boxes. How many boxes should the cook make? The monkey has an answer of 82 for this problem. But which strategy should he choose to explain it? Again, he needs to think about the numbers in the problem and pick an easy and clear way to explain. The number 39 is close to 40, and it's easy to add to tens. So the monkey's going to break apart the number 43. He uses a number line to show how he adds the parts of 43. 39 plus 1 plus 40 and plus 2 more. He proves that the cooks need to make 82 boxes of popcorn. In this lesson, you learned how to explain addition or subtraction problems by choosing appropriate strategies. How do you choose a strategy for explaining addition?
All right. So for this next part, you're going to need the worksheet for day 6 and a pencil. And we're going to read through the problem, we're going to create our model, create an equation, and then use a strategy to solve. If you notice, there's a lot of blank space on here. So that does not mean that we don't have to do as much work. We should be able to make sure that our answer is complete. We have evidence even when we don't have boxes that ask for it. So let's read this problem, and I want you to work this one along with me, okay? We're gonna do this one together. The gym cart holds 68 basketballs. The students picked up 32 basketballs. How many basketballs will still fit on the cart? We should know by now we need to look for that question. What's the question asking us? How many basketballs will still fit on the cart? Do we need to know how many in all will fit on the cart, or are we looking for a part that will fit on the cart? Will still fit on the cart. We already have some on there, so we're missing a part. So I know I can start with my bar model or my part-whole model, and I know I am missing a part. What information do we know? Can you already find the information that we know about this problem? We know the cart holds 68 basketballs. That's the whole. So 68 goes in the hole. The students picked up 32 basketballs. So they put 32 basketballs on the cart. How many basketballs will still fit on the cart? So what is that missing part? How many can we still put on that cart if we already have 32 there? We have our model, and we're going to create our equations. Remember, when we're missing a part, you can either subtract or you can add to find this answer. The first equation we could write is our whole, 68, minus the part, minus 32, is going to leave us with that missing part, equals x. We don't know. The other equation we could write is we could start with the part that we know, 32. We can see how many we need to add, and that's going to get us to our total of 68. Okay? So what strategies could we use to solve this problem? We've talked about base 10 models. We've talked about expanded form. We talked about the number line. I'm going to start by using base 10 models, and then we'll show one other strategy. 68 minus 32. I want you to go ahead on your paper and draw the rods and units for 68. Did it look like that? 6 rods, 8 units. Now we need to take away 2 ones and 3 tens. Do we have 2 ones to take away? Yes, we do. We have 8 of them. So we can go ahead and cross out 1, 2. I like to cross my numbers out up here just so I remember what I've done so far. And I circle what's left to help me stay organized. I need to take away 3 tens. 1, 2, 3. So go ahead and cross off 3 of your tens and circle how many you have left. This should be our answer. 3 tens and 6 ones. 3 tens and 6 ones is the number 36. Let's try the number line this time. Just draw a line, and we're going to plot the part we know, this 32. Let's see how much we need to jump to get to 68. Well, I know 32, the next friendly number would be 40. So to get to 40, we need to add 8. Now I can get from 40 to 60, because those are tens. How many tens does it take to get from 40 to 60? 2 tens. But we need 68. So we need to add another 8. So we started with 32. We ended at 68. What did we have to add to get there? That's x. Well, I know that 20 plus, I'm going to add my doubles first. 8 plus 8, that's 16. Remember, in my head, I can break apart 16 into 10 and 6. So this would be the same as 20 plus 10 plus 6. 20 plus the 10 is 30, plus 6 more would give me 36. That's what we got with our base 10 models. We cannot forget our label, 36. We're talking about basketballs. And let's check to make sure this is a reasonable answer. Make sure you have your bar model, your equation, at least one strategy written down. You don't have to do both, but it's good practice to do both. Is this a reasonable answer? If we have 36 as the missing part here, we found that out. It's about 40 plus about another 30. That would give us about 70. And 68 was the total, so 70 is really close to 68. Yes, it's a reasonable answer. All right, we're going to practice one more, and this time I want you to practice first. I'm going to read the problem, and then I want you to start creating your bar model and get your equation that you think we need to create to solve this problem. Trent wants to ride every ride at the park. The amusement park has 74 rides in the park. He rode 58 of the rides so far. How many rides does he have left to ride? What question are they asking us? What information did they give us? And then create your bar model. What is that question they're asking us? How many rides does he have left to ride? Are we missing the whole? Are we missing the total amount of rides there are? Nope, we're missing a part, so we have that missing part again. Trent wants to ride every ride at the park. That's information for the movie in our head, but not really giving us any numbers to solve. The amusement park has 74 rides in the park. That's the whole. And then our other part would be he rode 58 of the rides so far. So part of the rides is 58. We're missing how many he has left to ride, the other part. So 2 equations you could have written for this would have been start with the whole, subtract the part we know, and that should give us the other part. 74 minus 58 equals x. The other equation would be starting with what we know, the part, 58, plus how many do we need to add to get to 74? Go ahead and use a strategy to solve that problem. Maybe base 10 blocks, expanded form, number line, but go ahead and get your answer and label it. Right. I think I'm going to start by showing you the base 10 model. So if you use that strategy, check your work. If we have 74 to start with, we should draw 10, 20, 30, 40, 50, 60, 70, 71, 72, 73, 74. And if we're going to take away 8, I can't do that. So I have to ungroup one of those 10s, and we always say smash it into 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that's 10 ones plus the ones that were already there. We don't count those 4. You need to take this 10 and add 10 more ones to this side. So now we have enough to take away our 8. 1, 2, 3, 4, 5, 6, 7, 8, and I'm left with 6 ones. And then I need to take away 5 10s. 1, 2, 3, 4, 5 leaves us with 1 10. Now, if you use the number line and you started with 58, you needed to get to 74. So if you jumped 2 jumps, that would get you to 60. I need to get to 70, so that's a 10. A jump of 10 gets me to 70, and then 74 would be another jump of 4. How many did we jump? 10 plus 4 is 14, plus 2 more is 16. We have the same answer, 16 rides. I hope you wrote your label. Think if this is a reasonable answer. About 20 plus about 60, that's about 80. 74 was our total. Sounds reasonable to me. All right, I want you to do the last problem on your own. Make sure your answer is complete. Thank you for your hard work today, and you guys have a good day.